Okay, so our number 2 example is we have the 6 kg block, and the 6 kg block has a force of 100 newtons applied to the block, and it has another force which is the frictional force, which acts in the opposite direction to the applied force. Okay, so it says if the acceleration of the object above is 5 meters per second squared, calculate the magnitude of the frictional force. Okay, so remember that our frictional force always acts opposite to the direction of motion, so I know that this object is going to move to the right. And why is that important? That is important because when we have our net force, okay, we need to be able to work out in which direction our net force is acting. So the way we start is if net is equal to MA. If I look at this, we've got the applied force of 100 newtons and we got frictional force acting in the opposite direction. Did they tell us? Yes, they told us the acceleration. So for my resultant force, I'm going to say 100 newtons minus my frictional force is equal to the mass of the box was 6 kilograms, 6 times 5. This is one of the easier questions, and then I go 100 minus 30 is equal to my frictional force. Therefore, my frictional force is equal to 70 newtons. And as you can see, the direction is to the left. Okay, we can now mark number 3. And with the number 3, we go and have a look. And number 3 says a truck is experiencing a number of known forces. Is it possible to determine the direction of the motion of the truck? Explain. So this is a very interesting question. You have this truck, and the truck has got all sorts of forces acting on it. Okay, would you be able to tell us which direction this truck is moving? No, you won't be able to do that. The simple reason is that the resultant force will tell us which direction the truck is moving. So the resultant force tells us in which direction the truck moves. Sorry, not the resultant force tells us not in which direction the truck moves. It only tells us the direction of the acceleration. So just remember that. I think I got just mixed up there. It doesn't tell us in which direction the velocity is, but it tells us in which direction the acceleration is. Okay, and we can now go to question number 4. Okay, so for question number 4, it says a force of 25 newtons is required to just start a 5 kilogram box moving across a wooden floor. Calculate the coefficient of static friction. Okay, so we're using the equation frictional force is equal to mu s multiplied by n. Fairly straightforward question. This is 25. We don't know what that is. We know the mass of the object, and we know for the normal force that the normal force is equal to the weight because the object is resting on a flat surface. Okay, and from there we get our mu to equal 0,51. Remember, there are no units of measurement for this.